Good afternoon, Advanced Algebra students. I hope you are doing fantastic. I am excited to be doing your second lesson in Chapter 3 with you today. We started off with 3.1. Today we're on 3.2. This lesson I think is a lot more straightforward than yesterday's lesson. So we're going to be talking about adding, subtracting, and multiplying polynomials. Much of this is review, but I just kind of wanted to make sure that we're all on the same page moving forward. So the first example is just going to be an example of adding polynomials. So for example, 6x cubed plus 4x plus x squared minus 7 in parentheses plus 2x cubed minus 8x squared plus 3. Now, typically, it's not 100% essential, but it's considered common practice to write in what we call descending order, which means we have this highest exponent first, and then we go down from there. So the highest exponent that I have is to the power of 3. So I'm basically going to combine the 6x cubed with the 2x cubed and get 8x cubed. I like to cross those off to let myself know that, yes, I've got those. Now my next power down from 3 would be 2. So I've got a positive x squared and a negative 8x squared. When I combine those coefficients, I would have negative 7x squared. Again, I'm crossing out as I go. Now I have a 4x here, but none over there, so I just write down 4x. And then it looks like I have a negative 7 and a positive 3 that would give me negative 4 when I combine those. So that is pretty straightforward. We just combine like terms. Again, it has to be the same letter to the same power, and we're just adding the coefficients. Now, let's do an example, example number 2, when we have subtraction. So let's say, for example, we have in parentheses 6y to the 4th minus 5y cubed plus 7y squared minus 3y minus 4 in our first parentheses, and then minus in the second parentheses, 12y to the 4 minus y cubed minus 3y minus 9. Now, this is a matter of personal preference, but what I strongly recommend, because there is a minus sign here, this is an equivalent of a negative 1. Whenever we multiply something by negative 1, we change the sign. So what I like to do is make this a plus here, but then inside the parentheses, change the sign of everything. So if it was positive, it becomes negative. If it was negative, it becomes positive. That way it's easier visually for me to combine like terms. Then I do the same process that I did before. My highest power is to the power of 4. So I would take 6y to the 4 minus 12y to the 4 and get negative 6y to the 4. Now I want to look for power of 3's. I'm going to cross these out, and it looks like I have a negative 5y cubed and a positive 1y cubed. So adding those coefficients would give me negative 4y cubed. Then it looks like I have a 7y squared here and none over there, so I'm just going to cross that off and write 7y squared. The next one I would be looking at would be negative 3y and positive 3y. Those cancel each other out, so I don't need to bring them down at all. And then I've got a negative 4 and a positive 9, which would give me a positive 5. So it's fairly straightforward to add polynomials. Again, add or subtract them. All we're doing is combining like terms, and by doing that, we are adding the coefficients. Now, let's do a few examples where we are multiplying polynomials. When we are multiplying, we have to distribute. So for example, let's say we have 2m plus 5 times 3m squared minus 4m plus 2. The thing we want to keep in mind when we're multiplying is that we have to add our exponents. When we're combining like terms, we don't do that, but when we're multiplying, we do. So for example, when I take 2m times 3m squared, you want to think of that as being a power of 1. This would become 6m cubed. Then on the next one, 2 times negative 4 is negative 8, and 1 plus 1 is 2. Here there is 2m times 2 is just going to be 4m. We just have an n to the power of 1. Now, I kind of like to line things up. So, for example, when I work with a 5 and get 15m squared, I like to line that up underneath the negative 8. Here, I'm going to get negative 20m, and here I'm going to get 10. Then I'm again now combining like terms. Remember, when I combine like terms, I don't change the exponents. It's only when I'm multiplying that I do. So this would be 6m cubed plus 7m squared minus 16m plus 10. So that would be an example of multiplying polynomials. All right, let's do another example. Example number 4. This one was a binomial times a trinomial. Let's do 3 binomials. There's a few different ways to do this, and it's kind of like what is most comfortable to you. For me personally, I like to multiply the 2 binomials on the right using FOIL. So I'm going to do those 2, and then I'll end up with a trinomial on the right and a binomial on the left like I did up here. So I'm just going to bring down the 4x minus 1. And then I'm going to do the work for these 2. So I'm going to have x times 3x will give me 3x squared. Now in FOIL, remember I have an outside and an inside. So x times 2 is going to give me 2x, and 6 times 3x is going to give me 18x. When I combine the 2x from the outside and the 18x from the inside, that is going to be 20x there. And then the 2 last terms are going to be 12. Now that I've done that work, I can do exactly the same steps I did before. Multiply everything by 4x first. So this will be 12x cubed plus 80x squared plus 48x when I multiply everything by 4x. Now I'm going to take the negative 1 and distribute it to everything in my second parentheses, and I'm going to line everything up here. So I'm going to have negative 3x squared minus 20x minus 12. And then I'm left with, when I line everything up and combine like terms, 12x cubed plus 77x squared plus 28x minus 12. Now, something that does come up in your homework is the concept of closure. Closure in math means when an operation like adding, when an operation on members of a set, such as real numbers, always makes a member of the same set. So for example, if you add 2 real numbers, will you end up with a real number? So a set of numbers is closed if and only if the operation on any 2 elements of the set produces another element of the set. So let's do an example together. Let's do example 5. The question is the set of polynomials closed under addition and subtraction? So are polynomials closed under addition and subtraction? So when we did the addition and subtraction examples on the first polynomials, did we end up with a polynomial? And the answer is yes. If we add 2 polynomials, we'll get another polynomial. If we subtract 2 polynomials, we'll also get a polynomial. So we can say, let's see here. The exponents do not change. The sum or difference is still a polynomial. So yes, it would still be closed. All right. Is the set of monomials closed under multiplication? Are monomials closed under multiplication. So a monomial is one term. So for example, if I take 2x squared, that would be a monomial. If I multiply that times 3x to the cube, another monomial, will I get a monomial? And the answer is yes. I would get 6x to the 5th. In this case, the variable term will still have whole number exponents. So this is still a whole number exponent. So it's still a polynomial. In this case, we were just making a note of the fact that the exponents do not change, but it doesn't really matter if they do. The key question in both of these is our answer still a polynomial? And the answer is yes, it is. So this would also be a yes. Now, let's try this one. Example number 7. Is the set of binomials closed under addition? Explain. So is the set of binomials closed under addition? So for example, if I add 2 binomials, do I always get another binomial? The answer is going to be no. For example, x plus 3 plus x minus 3 is going to be 2x. So I have a binomial plus a binomial equaling a monomial. So that would not be closed. All right, there's one more example, example number 8, on writing a polynomial, a function. And again, I always try to give you problems similar to what you're going to see on the homework. And we will, of course, go over the homework as well. So here's the last problem. Carolina makes wind chimes to sell at the local Saturday market. As Carolina produces a greater number of wind chimes, she can lower the price per unit. The function v of x is equal to 48 minus 2x relates the price v to the number produced, x. The cost, c, of making wind chimes can be represented with the function c of x is equal to 12x plus 64. Again, x is going to be the number produced and the c is going to be the cost. How many wind chimes should Carolina sell each week to maximize her profit? So let's do a little bit of work on this one. Revenue is going to be the price per item sold times the number sold. The price per item sold is this function right here, the 48 minus 2x. And the number sold is x. So our revenue is going to be 48x minus 2x squared by distributing that x. Now, profit is going to be your revenue minus your cost. So the revenue, if we put this in standard form here with the highest exponent first, would be negative 2x squared plus 48x minus our cost up here, the 12x plus 64. Now notice there is a minus sign in front of the parentheses, so we're going to have to distribute that. So this is going to be negative 2x squared plus 48x minus 12x minus 64, or negative 2x squared plus 36x minus 64. Now, if we want to see what this function looks like, let's go ahead and graph it. Remember from last term that the x coordinate of the vertex this is a parabola because it's degree 2, is going to be negative b over 2a. Our b here is 36. So negative 36 over 2 times our a is negative 2. This ends up being negative 36 divided by negative 4, or 9. 9 chimes. So if we were going to graph this parabola, and I'm going to skip count by 2s just so it doesn't take up too much space. So 2, 4, 6, 8, 10, 12, 14, 16. 9 is going to be between 8 and 10. 2, 4, 6, 8, and 10. My axis of symmetry, and some of you are thinking, oh, I've forgotten all this. That's okay, we're going over it now. This is my axis of symmetry. It's the line x equals 9. And then, so I know that the x-coordinate of my vertex is 9. If I want to find what the y value is, I can find the profit at 9 by using this function right here, the negative 2x squared plus 36x minus 64, but putting 9 in for x. So we're going to end up with negative 2 times 81 plus 324 minus 64, or 98. So let's go ahead and plot on the y-axis by tens. 20, 30, 40, 50, 60, 70, 80, 90, 100. The vertex of this parabola is going to be at the point 9, 98. And we can graph it going down like this. So the question is, how many wind chimes should Carolina sell each week to maximize her profit? The answer is going to be 9. Maximum profit. The maximum profit is actually 98, but this is the number of chimes to get your maximum profit. Okay, I don't think that it necessarily said on these directions to do the graph. I think I just kind of did that as an extra visual for you. But you can see with a parabola that has a negative leading coefficient, remember it's pointing down, and so it's going to have a maximum. And so we're going to maximize profit when x is 9. I do believe there are 1 or 2 homework problems like that, so that's why I included that in there. I hope this has been helpful to you guys. I look forward to seeing you in class. Thank you. Bye.